Hello everyone, welcome back to CBSE Secrets of Science. In today's video, we are going to understand everything about the convex mirror. We learn what a convex mirror is, how light reflects from it, the rules for drawing ray diagrams, the image formed in different cases, and finally its real life applications. So let's get started. What is a convex mirror? A convex mirror is a spherical mirror whose reflecting surface bulges outward while the silver coating is on the inner side. Since its reflecting surface curves outward, the reflected rays spread away from each other. That's why a convex mirror is also called a diverging mirror. What happens when light falls on a convex mirror? Unlike a concave mirror, the focus and center of curvature lie behind the mirror. When a ray of light strikes the surface of a convex mirror, it gets reflected according to the law of reflection. The angle of incidence is always equal to the angle of reflection. Because the mirror curved outward, the reflected rays spread apart. If we extend these reflected rays backward, they appear to meet at a point behind the mirror called the principal focus. Ray diagram rules. To draw any convex mirror ray diagram, remember these two important rules. Rule 1. A ray parallel to the principal axis after reflection appears to come from the principal focus. Rule 2. A ray directed towards the center of curvature after reflection retraces its own path. These two rays are enough to locate the image. Convex mirror ray diagram. Now let's draw the ray diagram. First, draw the principal axis and the convex mirror. Mark the pole P, F and center of curvature C. Place the object anywhere in front of the mirror. Now draw the first ray parallel to the principal axis. After reflection, this ray diverges. Extend it backward using a dotted line. It passes through the principal focus. Next, draw the second ray towards the center of curvature. After reflection, it retraces its path. Extend these reflected ray backward. The backward extensions meet behind the mirror between the pole and the focus. This point gives the image position. Now let us see cases of convex mirror and the image formation. Now let's see what happens when we move the object. In case 1, the object is placed at infinity. That means the object is very far away. The reflected rays are almost parallel. The image is formed at the principal focus. So the image is virtual, erect and highly diminished. Now let's see case 2, where the object is placed at a finite distance. Now bring the object closer. Again draw the same two principal rays. The backward extensions meet between the pole and the focus. The image is virtual, erect, diminished and formed between pole and focus. As the object moves closer to the mirror, the image also moves slightly towards the pole and becomes a little larger. However, it never becomes larger than the object and never becomes real. So, irrespective of the object's position, a convex mirror always forms a virtual, erect and diminished image between the pole and the focus. Why does this happen? Since the reflected rays always diverge, they never actually meet in front of the mirror. Only their backward extensions intersect behind the mirror. Therefore, the image formed is always virtual. Because the rays spread out, the image is also smaller than the object, which is why it is called diminished. Now let us see the real life applications. A convex mirror provides a wide field of view because it forms smaller images while allowing us to see a larger area. That's why convex mirrors are used in many places, like rear view mirrors in cars, buses and motorcycles, security mirrors in shops and supermarkets, mirrors at road bends and blind turns, parking areas to monitor vehicles, corridors, hospitals, and banks for surveillance. In all these applications, the wide field of view helps improve safety. If you found this video helpful, don't forget to like, share and subscribe to CBSE Secrets of Science. Thanks for watching and I'll see you in the next video.